All right, welcome to video number 48. I have the young and the restless Matthew Lewis here, and I am the old and complacent Mr. Miller.
All right.
Let's do this. Together we got this.
Okay.
This is video 48. We're going to talk more about simplification. Yesterday we were doing problems like this. I'll give Mr. Lewis the pen here.
Okay.
And what we did is we broke the square roots up into a product of a perfect square and whatever's left. So up top, let's write the perfect squares.
Okay, I can do that.
So probably need a pen.
Oh, my bad.
That's all right. First perfect square is 1.
1.
Not very useful though. 4 is
4.
2 squared. 3 squared.
9.
4 squared.
16.
And then 25. 36. I peeked ahead. We need this one. 49.
Okay.
I think we're good after that.
All right.
All right. So the trick is find the largest perfect square that the number can be divided by.
Okay.
Let's just start going up the list.
Yeah.
So we try 52.
Okay.
If you do 52 divided by 4.
All right. I think I get 13.
Yeah, so we're going to break this up into the square root of 4 times the square root of 13. Cool. Now, one of those we can take the square root of and get a whole number, and one gives us a decimal.
Yes. Square root of 4 gives us 2, but this guy gives us some ugly decimal.
Yeah.
So we just like to leave him just how he is.
Very good. And that's considered simplified because instead of 52, we got it down to a 13 inside the square root.
Right.
All right, 92. 92 divided by 4 is 23.
Oh, mental math showing off.
And if you tried like 9 and 16 and 25, you get decimals. Like 92 divided by 9 is a decimal. So 4 is the largest one that works.
Okay.
So square root of 4 times the square root of 23. So that would be
2 times the square root of 23.
Done. Now, sometimes you might realize you can go further. Like we could break up like 23 again into a perfect square. But this time we can't. But sometimes you might be doing this and realize that you could keep going.
Yes.
All right, 150. That's 25.
Yeah. Do that for money. Think like $1.50.
Now, we usually put the perfect square one first, but Mr. Lewis did.
Yes.
But if you accidentally switch them, you gotta remember it's the perfect square one we can take the square root of.
Right.
Okay, so it's 25 times 6.
Yes, it is.
So 5 square root of 6.
Square root of 6.
All right.
Bam.
147.
47.
4 doesn't go into it. 9 doesn't go into it. 16 doesn't go into it. 25 doesn't go into it. 36 does not go into it.
Oh, so I guess 49 must go into it.
49 does go into it.
3 times?
Yep.
Ooh, this time I wrote it backwards.
Okay, well, let's see what happens when you write it backwards.
All right. Well, that guy, obviously you can't take the square root of 3.
You can, but it's ugly.
Otherwise it would be up in their little fun zone here.
Yeah.
So square root of 49 gives me 7 times the square root of 3.
Very good. So if you write it backwards, you gotta realize it's the one that's the perfect square. You can take the square root of.
You can write it like this. Just make sure that you separate them so you know, because otherwise it looks like the square root of 37, and that's not going to want to help us out at all. So
put the whole number.
We're gonna do it this way.
All right, here we go. Next. Okay, these are very similar, but they have a number being multiplied in front. So we're going to break up the square root the same way we always do. It's 6 times whatever we get when we break up square root of 20. So we'll go through this quickly. It's square root of 4.
Square root of 4.
And square root of 5.
Square root of 5.
So that's the same thing I did before.
Mm-hmm.
Now,
so 6
times 2.
2
times
the square root of 5.
And then we can do the 6 times 2 part.
12.
Yeah. Got it. So whatever we would have gotten, we just multiplied by 6. All right, next one. 63 is 9 and 7.
4 times 3.
Yeah.
Times 7.
Yep.
12 square root 7.
Got it.
Bam.
All right. What about this one?
5 times square root of 4.
Yeah.
Times the square root of 3. 5 times 2, root 3, which is 10, root 3.
All right.
Ooh,
you gotta do
negative.
Like Mr. Lewis. All right. Now this one, 4 goes into 32, but we can do better.
Yeah, I think 16 would probably be the best guy to do.
Yep.
So, again, 4 wouldn't be wrong.
No.
We would just probably add another step
Yeah.
to your solution.
Okay.
And since, we're not left with, I guess we're left with more space, I'm just focusing on the white.
Times 4.
2. Negative 12 root 2.
All right. Time for something else a little bit new.
All right.
What if they're variables?
Variables.
So on this one, we're looking for what will we multiply by itself to get x to the 6?
X to the 3rd.
Yeah, so maybe we could write x to the 3rd times x to the 3rd is x to the 6th. We haven't talked a lot about exponents yet.
No, but you add exponent when you are multiplying exponents, because you think of this as x times x times x times x times x times x. There's 6 x's there.
Right.
So same thing as x to the 6th.
Yeah, so you think, what do you multiply by itself to get x to the 6th? X to the 3rd. So
Right.
it's kind of nice when it's even. You just divide the exponent by 2.
Yes.
All right, so x to the 3rd is the answer to that. Okay. Then x to the 10th.
Mm-hmm.
What do you multiply by itself to get x to the 10th?
Well, x to the 5th
Yep.
divided by 2.
And x to the 4th is going to be?
X squared.
Good. Now,
Bam.
when it's odd, it's a little problem. We're going to break it up.
Well, odd. Probably we just want to go to the next closest even number
Yeah.
before it.
We're going to split it up into square root of x to the 6th
X to the
times
6th.
square root of
X.
Because x to the 6th times x is x to the 7th. So it's
Right.
kind of like before. We split it up into a nice part and then a part we're stuck with.
Right.
So it's going to be x cubed.
Cubed times square root x.
I just heard a bunch of people go, oh, what? That's okay. Once you get the hang of it, variables are actually easier than the numbers to do. All right, this one's odd, so we're going to break it up into 14 and 1.
Yep. 14 times square root x
So x to the 7th
times square root of x.
good. 11 is going to be the same thing.
Square root of x 10 times square root of x. Be x to the 5th times square root of x.
All right, but actually, that was it for how do you handle variables.
Yeah.
So we'll go over that some more in class, but you just saw everything for the variables. All right, last 2 examples. So we want to talk about like one place where square roots come up, and it has to do with Pythagorean theorem.
Mm-hmm.
And actually, that's important because the distance. Often when you compute distances, they're going to be square roots.
Right.
Okay, so here we're going to do the a squared plus b squared equals c squared. Okay, remember a and b are the legs of the triangle, and c is the hypotenuse which we're trying to find. 16 and 64 is 80.
Yes.
So I want to pause for a minute. This is saying c squared is 80. So what number times itself is 80? That's the job of
Square root.
square root. So we get c equals the square root of 80.
So square root of 80 equals c.
And we were so cool at simplifying. We're going to simplify that.
Yeah.
So we could find a decimal if we want. It's just under 9. But we can break this up into 16 and 5.
4 square root 5 equals c.
Yep. So maybe you've seen the Pythagorean theorem before, but I don't know if you did it and simplified your answer. And on some college placement tests like the ACT, this is how often the answers are presented.
Yeah.
Simplified radicals. All right, let's do it again. We got a squared plus b squared equals c squared. So 4 squared plus 6 squared.
Okay.
And let's label c. I didn't label it in that triangle. So there's c.
So 16 plus 36, c squared. And we get 52 equals c squared. So that means the square root of 52 is c.
A little bit more than 7. It'd be like 7 point something.
Right.
But we want an exact answer. 4 and 13, I think.
Yes, we did that one earlier.
Oh, yeah. I remember. I'll never forget a simplification. So it's just 2.
13 equals c.
Awesome! Guess what time it is? You made it. That was a
think
lot
it's
of
journal
math.
time. It was a lot of math.
This was a quality video with a lot of stuff in it. All right, so simplify the following. So you have two of the basic ones, two of the ones with a number in front, and two variable ones. Then use the Pythagorean theorem to find the missing side.
Sounds like a whole day.
You might want to do it twice. All right, see you next time.